Hi, I'm Sarah, and today I will be giving a review of Chapter 5, the Integumentary System. To begin, we're going to talk about the components of skin, or the major components of skin, which are the epidermis, the dermis, and the hypodermis. But to begin, I will talk about the epidermis. So the epidermis is the most superficial layer of the skin made up of stratified squamous epithelium. It is avascular, meaning there is few to no blood vessels. The major cells in the epidermis include keratinocytes, melanocytes, Langerhans cells, and Merkel cells. So keratinocytes are the most common type of cell in the epidermis, and the keratinocytes make cells waterproof and abrasion resistant. Melanocytes is the second type. Melanocytes produce a brown pigment called melanin, which helps protect us from UV rays. So that's an important one. Langerhans cells, these are cells that eat, called macrophages. And what do they eat? They eat any foreign invaders that might hurt the immune system. And the last cell in the epidermis is Merkel cells. And these are receptors. These are more sensory receptors in the skin. So moving on to the dermis. The dermis is made up of dense irregular and areolar connective tissue. It is vascular. And two of the main layers in the dermis is the papillary layer and the reticular layer. The papillary layer consists of dermal papillae and dermal and epidermal ridges. The papillary layer is the thin upper layer and areolar connective tissue. The dermal papillae are projections housing nerve endings, and they contain Meissner's corpuscles, and those detect light touch. This also gives the epidermis something to grab onto. The second structure in the papillary layer is the dermal and epidermal ridges, and these are our fingerprints, which detect vibration and texture, or help to feel those things. Next, the second main layer of the dermis is the reticular layer, and that is made up of lines of cleavage and flexion lines. So lines of cleavage are also called tension lines, and they represent the direction of most of the collagen fibers, which can run circularly around the trunk and longitudinally in the limbs. The flexure lines are places where the dermis is attached to deeper structures. So there's also the hypodermis, but there's not much to say about that because the hypodermis, also called the subcutaneous layer, is not really a part of skin, but underneath the skin. So moving on to the layers, there's layers in thin and thick skin. To begin, we start with the stratum basale, which is the bottom layer. It is the deepest layer. In this layer, a single row of cells on the bottom of the epidermis undergo rapid mitosis. The next layer up is the stratum spinosum. This is also called the spiny layer. The stratum granulosum, also called the granular layer. The stratum lucidum, also called the clear layer. The stratum lucidum is only found in thick skin, so it's not a part of thin skin at all. And the last is the stratum corneum, which is in thin and thick skin, and this is the thickest layer of all, also called the horny layer. So moving on to skin color, there's two main pigmentations of the skin, keratin and melanin. So keratin is like a yellow-orange pigment, and this is found in the palms of the hands and the soles of the feet because there's no melanin there. Melanin, as we talked about a little bit earlier, melanin is produced by melanocytes, and this gives the skin a brown pigment to protect us from UV rays. However, the UV rays can blast chemicals in DNA apart and cause mutation, and that is how skin cancer happens. There's also abnormal coloration though. These are normal, but the abnormal skin coloration consists of cyanosis, erythema, pallor, and jaundice. So cyanosis means there's low oxygen levels, so you get that blue color in the skin. Erythema is blushing or fever. Pallor is like when you're very pale, like if you have fear or you're very afraid. And jaundice is yellow, a yellow color contributed most likely by liver problems. So some main functions of skin include protection. Under protection is chemical, physical, and biological barriers. There's also body temperature regulation, cutaneous sensory reception, metabolic functions, blood reservoir, and excretion. So under chemical barriers, skin has sebum that has a lower pH, which inhibits the growth of pathogens. Physical barriers include the skin being waterproof, and that helps keep foreign invaders out. And biological barriers is the skin having Langerhans cells, which we discussed earlier a little bit. And the Langerhans cells have macrophages, cells that eat, and they help eat the bacteria. The body temperature regulation, pretty self-explanatory. It deals with homeostasis to just maintain a normal body temperature. Cutaneous sensory reception is like your sense of touch, temperature, and pain. It lets you know when your body is being damaged. So that's an important one. And then metabolic functions activate vitamin D, which helps absorb calcium. The blood reservoir is about 5% of your blood, and excretion is the skin excreting urea and ammonia. So moving on, some homeostatic imbalances of the skin include striae, blisters, and the effect of UV rays. So striae are stretch marks, and these are places where the dermis is torn. Blisters is where the epidermis separates from the dermis, and that space fills with fluid. And the effects of UV rays, as we know, UV rays cause skin cancer. And they cause skin cancer because the DNA mutates in the skin cells. This can cause the skin to lose its elasticity. And we have a hematoma, which is clotted blood underneath the skin, like a bruise or an angry place. So now moving on to skin cancer. There's a few different types: basal cell carcinoma, squamous cell carcinoma, and melanoma. Basal cell carcinoma, if you get skin cancer, you're going to want to hope it's this one because it is the least malignant and the most common type. It's slow growing and enclosed, and it does not spread. This comes from the stratum basale. Next up is the squamous cell carcinoma, and this comes from the stratum spinosum. And last but not least, we have melanoma. And melanoma is a very serious and deadly type of skin cancer. This kind of skin cancer spreads very quickly, and it comes from melanocytes. It is very resistant to chemotherapy as well, so it makes it even more dangerous and harder to treat. So there is an A, B, C, D, E rule when you have a spot. The A is for asymmetry, B, border regularity, C, color, D, diameter, and E, evolution. So asymmetry is when you're looking for if one side is like bigger or smaller than the other. Border irregularity is just looking to make sure there's no irregular border around the spot. C, for color, there can be dark and light spots on the area. There can also be like blue and red colors, so if you see that, you're going to want to get it checked out. D is for diameter. If it's bigger than a pencil eraser, it's probably not good. And E is just for evolution. How is the spot evolving? So for burns, there is a rule of 9s, which is the percentage of body surface burned. And how this works, for a little quick overview, is it divides, the rule of 9s divides the body into 11 sections, each counting for 9% of total body area, plus an additional area surrounding the genitals, accounting for 1% of body surface area. As you probably know, there's first, second, and third degree burns. First degree burns meaning the less severe, third degree meaning the more severe. First degree burns means you've burned the epidermis. A classic example of this is a sunburn. For second degree, it means you've burned down to the dermis, and this one can be one of the more painful burns to have because you get blisters, which, as we talked about, blisters are when the epidermis separates from the dermis and the space hence fills with fluid. The third degree is the more severe because that means you've burned through the epidermis and through the dermis down to the nerve endings. So you might not feel the pain you're in because your nerve endings are burned, but they usually look pretty severe, these kinds of burns. So now for glands. So we've got sweat glands and oil glands. Sweat glands are also called sudoriferous glands, and there is merocrine and apocrine sweat glands as the two main types. So merocrine sweat glands are found in the forehead, the palms of the hands, and the soles of the feet. They use merocrine style secretion, also called exocytosis, to release their products, which is the sweat. They also do thermoregulation. The second main type of sweat gland is apocrine sweat glands, and these are more of your stinky sweat glands because they're found in the axillary and anogenital areas. Their ducts empty into hair follicles as well. Mammillary glands are like modified sweat glands, but it has its own little separate division because it's not a main type of sweat gland. We've got the ceruminous glands, which makes earwax. It's found in the ears, and the earwax helps keep things out like bugs in your ears and all that fun stuff. And then sebaceous glands is your oil glands. The sebaceous glands secrete into hair shafts, and their product that they secrete is sebum. Sebum is oil. These glands use holocrine style secretion. The sebum, the oil, is a good, it lubricates your skin. And these are located everywhere except the palms and the soles of the feet. And I also forgot to mention in the beginning, some key accessory structures of the skin include the hair and the nails. So hair does things like keep the sweat out of eyes, keeps bugs out of your eyes through your lashes. They also provide sensory reception and some protection from impact. And then for the nails, your nails provide extra friction and help you scratch and pick at things. And that was my presentation of Chapter 5, the integumentary system.